Alright, today we're going to find the integer solutions to these two equations, and we will start out by making a little assumption, and we can make this assumption without loss of generalization. We can assume that A, B, and C is greater or equal than 0. And we can do that because if we look at A squared, well, that's the same as minus A squared. So if I have a solution A, then I know that minus A is a solution as well. So if we figure out that A is 8, well, we know that minus 8 is a solution as well. So we will make the calculations with A, B, and C greater or equal than 0. And then we'll notice that if I have A squared minus B squared, it's 21, and more generally it's greater than 0. And because it's greater than 0, I can add b squared on both sides without changing the unequal sign. So a squared is greater than b squared. And because that's greater than b squared, well, then a is greater than b, again, because we have assumed that a, b, and c are greater or equal than 0. Right. Okay, and if we look at b squared minus c squared, we can see that that's greater than 0 as well. More specifically, it's 20, and that's greater than 0. And if we add c squared on both sides, then we get b squared, which is greater than c squared. And again, we have positive numbers, so we know that b is greater than c, which is greater or equal than 0. Now, if we look at b squared minus c squared, and we write that up, b squared minus c squared, we know that that can be written as b minus c multiplied by b plus c. So b is positive, and c is positive, and c is less than b. So we know this parenthesis is positive, but we also know that it's smaller than this parenthesis because both are positive numbers. So we know that b minus c is smaller or maybe equal to b plus c. And we also know that this has to be 20. That was the assumption when we started the assignment. B squared minus c squared equals 20. So we have to figure out which numbers do I multiply together to get 20. And remember, we have integer solutions, so the parentheses will be integers as well. So if we first assume that this is 1, this is 1, then this must be 20. If we assume that this is 2, then this must be 10. We can assume this is 3, but this will not give an integer solution to this. So I will cross this over, and then we can look at 4, and if I have 4, this parenthesis will be 5. So these are the 3 possible solutions to these parentheses when it needs to be 20. And if we look at these 3 solutions, we can try them out and say, well, if we have b plus c plus b minus c, this is just something I write up to see what happens. If I see this parenthesis plus this parenthesis, 1 plus 20, that's 21. And if I look at this, I will see that c cancels out with c, so that this gives us that 2b equals 21. So b equals 10.5, which is not an integer. So this is not a solution either. We cannot use this. Let's try with the next one. 2 and 10. Again, if we add these parentheses, we will get 12, which also tells us that b equals to 6. So if we look at this, we can see that b is 6. 6 squared is 33, and this needs to be 20, so 36 minus something squared equals 20. That must be 16, and C must be 4. Okay, so this is a possible solution. We do not know if it's a solution yet, but it is a possible solution. Now, if we look at this, then we have 5.4, that's 9, so 2b equals 9, and that gives us that b equals 4.5. And that's not integers, so this is not a solution as well. So the only possible solution is b equals to 6 and c equals to 4. Now remember, we also need that a squared minus b squared equals 21. So a squared minus 36 must be equal to 21. So a squared must be equal to 55. There are no integers where this is possible, so there are no solutions to this problem. Well, the solution here was that there are no solutions. If you want to watch a video where there are solutions, please click on this link over here where I solve another problem on simultaneous equations. If you have a better solution to this problem, please let me know in the comments.
Alright, today I'm going to do something a bit controversial, and I'm going to assume that 0 is a natural number. Don't lynch me, let's take the debate in the comments and let's solve this equation. Alright, find the natural solutions to this equation. So first I will rewrite this equation, and I'll rewrite it by saying a plus 2ab equals 8 minus b. And then we can rewrite it again to say a parentheses 1 plus 2b equals still to 8 minus b. Alright, and we can use this the brute force way. Now remember, we're going to find the natural solutions, and I am assuming that 0 is a natural number. So we can brute force now test the possible solutions. And let's start out by saying b equals to 0, and be ready to lynch me in the comments. I know. But we're looking at this, and then we're saying a times this parenthesis, so that's a times 1, that is just a, that equals to 8 minus 0, so 0 disappears and a equals to 8. Now this was one solution, and the next we're going to try out is b equals to 1. And if we look at this, then the parentheses will be 1 plus 2, that's 3a, and it'll be 8 minus b, so that's 3a equals to 7, and that's a equals to 7 third. This is not a natural solution because this is not an integer, so this does not hold. Now the next we're going to try is b equals to 2, and if b equals to 2, then we will get the parentheses 1 plus 4, that's 5, so that's 5a, and that equals to 8 minus 2, and 8 minus 2, that's 6. So a equals to 6 over 5. Again, not an integer, so not a natural solution. Now, as we see, the right side is getting lower and lower and is decreasing. And when we say b equals to 3, we will see that this gives 7, this gives 1, so 7a equals to 1, and that's a equals to 1 over 7. Now we have, again, this is not a solution. And now we'll see that when b is increasing, then a will decrease. And it will decrease the way up to b being equal to 8, then a will be equal to 0. So there were two natural solutions if we assume that 0 is a natural number. Can you find the other integer solutions? Or do you want to debate whether is 0 a natural number? Let me hear in the comments below, or watch this playlist where I solve even more problems. Thank you for watching. Welcome to the vector space. We will solve this equation today, and we will start out by looking at the right side, and we will notice that log 10 2x, that is equal to log 10 of 2x, that is equal to ln to 2x divided by ln to 10. This is a standard logarithm rule. So the left side we can replace with this. So we have ln to 2x divided by ln to 10, which is equal to ln to 2x. All right, and how can we solve this? Well, we can start out by subtracting the left side on both sides. So we'll take ln to 2x divided by ln to 10 minus ln to 2x divided by ln to 10, and this is equal to ln to 2x minus ln to 2x divided by ln to 10. And obviously the left side here is 0, so 0 is the right side. Well, we can take ln to 2x and put outside of a parenthesis, so we get ln to 2x multiplied by 1 minus 1 over ln to 10, right? We'll just continue up here, and then we'll notice that we can divide by this parenthesis on both sides, and if we do that, we will get obviously 0 on the left side, and on the right side this will disappear, so 0 equals ln to 2x, and now we can take e on both sides, so e power to 0 equals e power to ln to 2x. And when we know how e works, well, we know that e power to 0 equals 1, and we know that e power to ln, those are opposite functions, so e power to ln, that will just be 2x, and this leaves us with x equals a half, which we probably could have guessed, but now we have calculated it as well.